Here I'm asked to solve a radical equation where the radical is already isolated. So let's just go ahead, step number one here, and square both sides. When you do that, you'll be left with the argument here, 64 minus 11x equals, now x minus 8 times x minus 8, when you distribute, will give you x squared minus 16x plus 64. Okay? Once you see that it's quadratic, you know you have to get it equal to 0. So when I add 11x to both sides, also at the same time I'm going to go ahead and subtract 64. We'll have 0 on the left side equals x squared minus 5x. Now factoring that, notice we have a GCF, x times. Well, if we factor out an x, we'll be left with x minus 5. Once it's factored, you then set each factor equal to 0. So either x equals 0 or x minus 5 equals 0. Adding 5, x equals 5. So here we have two possible solutions. Remember, when you square both sides, you have to check your solution. So let's check x equals 0, see if it works. So what we have here is 64 minus 11 times 0. The question is, does that equal 0 minus 8? Okay, does the square root of 64 equal negative 8? Okay, the answer to that is no. 8 does not equal negative 8. So it turns out x equals 0 doesn't work for the original. Let's go ahead and substitute in 5 and see if that one works. Okay, so again, 64 minus 11 times 5, does that equal, as a question, 5 minus 8? Okay, 64 minus 55 is 9. Certainly 9 does not equal negative 3. Square root of 9 does not equal negative 3. So x equals 5 is an extraneous solution as well. When you throw away both of your possible solutions, that's telling me the answer to the original equation is that there's no solution. The original equation is inconsistent.